Greetings, my name is Sofia Guzman, and in this video, I'll be presenting my last process automation final project for the course. My project is the potato chips rejection system, which is a potato chip rejection system is a conveyor that sorts finished potato chips when a series of LDRs, which is light-dependent resistors, identify the burnt chips. They are discarded by 8 blowers arranged in series. The objective of this project is to automate this continuous process with discarding the burnt chips and using the software Logix Pro 500. The specifications for this project is to use one light source with corresponding sensors, which the sensors used in this automation project is LDRs, which include 8 blowers. The LDRs will be arranged corresponding with the same amount of blowers. The LDRs will be activating the blowers with a 2-second delay. The recommendations provided by the professor is to create an input-output table with their functions and addresses, the program, and simulate the ladder logic for all 8 sensor blowers. I'll be presenting the first file and the second file, which the first file is with 2 blowers, 2 LDRs, while the second files will be 8 LDRs and 8 blowers. This is the materials presented for the project, which includes the conveyor, the LDR, the blowers, the start and stop push button, the light source, and the PLC, which in file 1, we only have 1 conveyor, LDR, 2 LDRs, 2 blowers, 1 set of start and push buttons, and a light source, 1 light source with 1 PLC. The only difference in the file 2 is that there will be 8 LDRs and 8 blowers. This is the illustration provided by the professor of the system, of the potato chip reject system. Here we see our input and output table for the first file. See, we have our start with our address, which is slot 1, bit 0. Stop, input 1, slot 1, bits 1. Here are our outputs. This is our physical inputs and our physical outputs. Here's our internal relays, which are the internal memory of the automation. The master coil will be responsible of turning the system on, like the conveyor and the light, which will also turn on the LDRs and the blowers. Will activate the LDRs, which the LDRs will be activating the blowers. The coil bit, which activate the LDRs, and the OCR, which will control each LDRs, which is in one physical event. Is the table continuing with the LCR, the LDR for the fault timer, blower, 01, runtime. This is the timer for the runtime, which I established to be 0.3 seconds. The fault time is the activation time of the blower, which is 2 seconds, and the runtime for the blower, I decided to be 0.3 seconds. For the sake of explaining the logic, I decided to divide the programs in two blocks. Block A, which is the startup. This block manages the system start sequence and activates the conveyor. When the start button is pressed, the master coil energizes and the light source turns on, allowing the inspection area to operate. Once the system is running, the conveyor motor remains active to move the ships through the inspection zone continuously. Block B, which is a blower control. This block handles the detection and rejection of the ships. Each LDR sensor detects the presence of a burnt ships and trigger its corresponding blower after a set of delay. The timer ensures proper synchronization between ships detection and blower activation, which is the 2 seconds delay activation, making sure that each burnt ship is accurately removed from the conveyor line. I start out by explaining block A, rungs. Rung 00 is the system latch where the start and the stop buttons are placed. It energizes the system and allows the power to the light source and the conveyor. Rung 001 will activate the conveyor motor with the master coil. Our rung 002 will activate the light source with the memory of the master coil. Rung 003 starts off the block B. Rung 003 is the event where the LDR detects the burnt ships. The OCR trigger once the LDR, meaning that once the LDR is activated, it will turn off, but it will latch the blower. So the OCR trigger once and the internal relay latches the event. Rung 004 is the transport delay, is where I establish a timer of 2 seconds delay before the ship reaches the blower. The rung 004, it's where the blower is energized for 0.3 seconds to create a pulse. This 0.3 seconds, I decided to use this time just so, because I decided not to let the blower stay on. If all the LDRs are activated and I do not use the OCR or the 0.3 timer of activation, all blowers might stay on, all 8 blowers. So I continue with the rung 006, which is the time where it's actually energized. EN means energized. Is activated and turns off automatically after the pulse. Rung 007, event reset. This is where the latch is unlatched. So after this rung, the blocks will continue with B1, B2, B3 until B8, which these runs will be repeated for all the 8 LDRs and 8 blowers. Here is the startup block. In the file, I actually described the beginning as block A startup. Here I have my normally open start push button which is parallel with the master coil to create a latch. The stop is normally closed, and my output will be the master coil bit, which will create the memory. Therefore, the next row, which is 001, will be my input to activate the conveyor motor, which is the output. Also, this master coil activates the light source. Here is where I start off my block B, how I explain block B01, which will start off the first blower. And it starts off with the rung 003. The master coils holds the memory of activation, which will activate also the LDR. The OCR is responsible for that one physical activation of the LDR. And here I create the latch or the set, which I decided to name coil bit 01 with slot 0 bit 1. Therefore, in our next rung 004, it's our input. And here we decide to create our timer on delay. It's what it says. This is our timer with the address 0. If I write on the preset 20, I'm actually saying it's 2 seconds. And here I'm activating the blower with the delay. This is the done delay. Done, DN as in done. This is for the LDR fault timer, which will activate the energizing blower time, which is 3 seconds, 0.3 seconds. This 0.3 seconds, the address will be used as the input for our next rung, which will energize, energize our blower. To close the block, I use the activation blower time, the address and in the slash I wrote DN as in done, letting it know that the process is done, and unlatching the coil bit. Also, it can be set that it was set and then reset. The blocks that follows have the same rungs, the same programming, nothing will change, only the address, but it is virtually the same. Here I continue off with the file 02, which is the continuity of the remaining 6 LDRs and blowers input-output table from file 01. It's the same explanation, only with the corresponding addresses. Everything is the same, only the addresses change. Up to blower 8, LDR 8, blower 8. The last timer is 15, the address 15. Here I decided to start the logic ladder by showing the startup block, so you can see that it's the same. I'm going to show you how the blocks are seen. Block 1, as I already explained, is everything the same. Block 2, the same. Continue with block 5, block 6, block 7, and block 8. So now I'm going to show you the simulation, the demonstration. So let's go to Logix Pro. Oops. Okay. So here I have my simulation for the input and outputs. Let me just before starting, let me be sure to download the program. Okay, just give it a second. Okay, so let's run the program. Okay, I should have reset the program, reset simulation. Yep, as sound effects. Okay, it didn't work. So let's start off by showing the stop button. As we can see, it works. So let's start off with the start now to activate the system. Since here we go. So it's working. Since it has a latch, I can unpress the button and the activation will remain. So let's start off with, okay, our blower 1, which is slot 2, bit 2, and our LDR, it's our input slot 1, 2. So 1, 2. Remember, it has an activation delay for 2 seconds. So, oops, okay. I'm gonna do it again so you can visually see how the OZR function. So I will press and unpress, and the program will still run the same. The OCR helps that one-time activation. And there you have it. This is the file 2. It's easier for me to show you the file 2. Okay, so let's go to 1.3. Has that delay, and the activation, it's short. It's actually, like I said, 0.3 seconds. So if I go to my last blower, which the address for the input is 19, it's over here. Oh, works perfectly. I'm gonna go randomly 5. Oops, and there you have it. Let's press the stop button again, just for safekeeping. And there you have it. We have a complete program for the potato chips reject system. So, thank you.